Okay, what I'm going to talk about is I'm going to talk about graphing linear equations. Okay, this only works for lines. There are a variety of ways to graph linear equations. Okay, just because this is something I'm showing doesn't mean that other methods you might have learned elsewhere don't work. But this is what I show students when they're first starting out with graphing or they need a review. Okay, so I basically use incomplete ordered pairs where I'll have an x coordinate and a y coordinate. Okay, x is your left, right, y is your up, down, and I leave one of them blank. Okay, depending on what the equation type, what form the equation takes. Okay, so for instance, this would be y equals something times x plus or minus a number. There may be a number there, there may not be. So you could also apply it to this. I use 0 blank and 1 blank. Okay, if that's an integer or decimal. If it's a fraction, y equals a fraction times x plus or minus some other number, then I use 0 blank in the denominator blank. If you have something times x plus or minus something times y equals a number other than 0, I use x equals 0, y is blank, and x is blank, y is 0. Okay? If the whole thing equals 0, I solve for y and use one of these cases. And then one variable equations, you're either going to get a vertical or horizontal line. I will show examples of each. Okay? So I'll start with example 1, y equals negative 6x plus 8. Okay? Well, that's an integer. This is an integer. It's y equals, and it's an integer, so I'll use this one. So I have 0 blank and 1 blank. Okay? So this means x equals 0, y equals we don't know. This means x equals 1, y equals we don't know. Okay? So for this one, y will equal negative 6 times 0 plus 8. And 0, negative 6 times 0 is 0. 0 plus 8 is 8. So that means x is 0, y is 8. Okay? For this one, we'll have y equals negative 6 times 1 plus 8. Negative 6 times 1 is negative 6 plus 8, I get 2. So this point will be 1, and the y coordinate will be 2. I have 2 points. All I need is 2 points. So 0, 8, left, right, nothing. So this represents your x-axis, this represents your y-axis. So 0, 8 is left, right, nothing, up 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay? 1, 2. So x equals 1, y equals 2. Okay? And I'm going to do the best I can graphing this very steep line. All right. And ladies and gentlemen, that is example 1. Okay? So let me go ahead and get this cleaned up. Actually, let me pause. All right, so here's example 2, y equals 5/7 x minus 3. Well, folks, that's going to be y equals, and it's a fraction times x plus or minus a number. So I will use this case B. So I will use 0 blank and the denominator blank. So the denominator is 7, so I will use 7 blank. Okay, following case B. The denominator is 7. So this means x equals 0. This means y equals we don't know. This is x is 7. This is y equals we don't know. Okay? me go ahead and make it more clear that that is a 7. Okay, so y equals 5/7 times 0 minus 3. Anything times 0 is 0. 0 minus 3 is negative 3. So the y is negative 3. We have 0, negative 3. All right, over here, y equals 5/7 times 7 minus 3. Well, 7 divided by 7 is 1. 5 times 1 is 5. We get 2. So this will be 7, 2. So 0, negative 3. 0 is my left, right. Negative 3 is down here. And the y coordinate will be, or the x point, x coordinate will be 7. 3, 4, 5, 6, 7. And then up, down is 2. And I proceed to put the line through. Or try to. It's easier to do this on a whiteboard or paper with a straight edge. But I don't have a straight edge handy. So that looks like it's close enough. And that handles example 2. Okay? Okay, continuing onward, I have example 3, 4x minus 7y equals 14. That's not y equals, so it's not a case A nor B. Case C, okay, for ax plus or minus by. So I got something times x plus or minus something times y equals a non-zero value. I would use this pair. So that would give me, I would use 0 blank and blank 0. So this means x equals 0, y equals we don't know. This means x equals we don't know, y is 0. So to handle this pair, I will have 4 times 0 minus 7y equals negative 14. Okay? So 0 take away 7y is, well, that's 0. 0 take away 7y is negative 7y. Okay? Divide off the negative 7, divide off the negative 7. Y is 2. So we have 0, 2. Okay, over here, I will have 4, x is unknown, minus 7 times 0 equals negative 14. And that's 0. 4x take away 0 is just 4x. So 4x is negative 14. Divide off the 4. And x equals negative. This reduces. They're both divisible by 2. So negative 7 halves, which is not very helpful when it comes to graphing. Okay? So what I'll simply do is I'll pretend I don't know what the answer is. I'll grab my calculator. I'll do negative 7 divided by 2. If my calculator doesn't give me a decimal, immediately I'll hit the conversion button and my calculator will give me negative 3.5. So we have negative 3.5, 0, because x is negative 3.5, y is 0. Okay, so 0, 2, left, right, nothing, up, down, 2. And then 3.5, left, x equals negative 3.5, and then 0. All right. And then put the line through. Oops, it's a little off. Okay, so negative 3.5 is right here. Let's try again. All right. And there is a sketch of the line that matches this description. I'm going to pause here again and set up another example. Okay, now what I did is I took, for example, 4, instead of what I had before, I now have 0, making it match that. Okay? Which will give me one of these two cases when I solve for y. Okay, so I will subtract the 4x. Okay, I'll try to do it more neatly. Negative 4x. So negative 7y equals negative 4x. Okay? Divide off the negative 7 because I'm solving for y. Negative 4x over negative 7. And y equals, the negatives will cancel, and I will have 4/7. I'll factor the x out of the numerator. Y equals 4/7 x. So since that's a fraction, it's y equals a fraction times x. It's more like that case where k would equal 0. Okay, so there's a unstated plus 0 here. So I will use 0 blank and 7 blank. All right. So x equals 0, and y equals we don't know. X equals 7, y equals we don't know. Okay? So y would equal 4/7 times 0, which is 0. So we end up with 0, 0. Okay, next up I have y equals 4/7 times 7. 7 divided by 7 is 1. 4 times 1 is 4. So we end up with 7, 4. So 0, 0, and 7. 1, 2, 3, 4, 5, 6, 7. And then up 4. All right, I'll put the line through. And ladies and gentlemen, that's example 4. Okay? Pause again. Okay, so now I resume with y equals negative 6. Folks, this only has one variable. So it's a one variable equation. Y equals k will give you a horizontal line. Okay? Okay? And all of its y coordinates will be negative 6. So if x equals 0, y is negative 6. Okay? If x equals 1, y is still negative 6. Okay? So, that's it. Okay? That's all there is to it. So, let me get it off the board. I'll just go ahead and erase it. This shouldn't take very long. Okay, so here's example 6. X plus 7 equals 12. Okay, and again, you're graphing this in two variables. Well, first of all, it's a one variable equation. So let's get x by its lonesome. So I would subtract the 7, and x equals 5. That's going to be a vertical line. at x equals 5. So all the x coordinates will be 5. So 1, 2, 3, 4, 5. Okay? It's going to be a vertical line through x equals 5. All right? Let me try to make it look more vertical. What I saw on the computer screen was not vertical. All right, so obviously, if it would start out like that, that's where you would go. Okay, so I have shown you all of the things that happen here. It's going to be your responsibility to recognize which case to follow, which based on looking at the equation. So now I will be doing mixed examples, starting with, let me get this off the board, okay, and I'll start doing a new example. Okay, my next example is x plus 6y equals 8. Okay, well, I'm going to have to look down the list of possibilities. Okay, I don't have y equals or y equals, so I'm not going to be using that for either of them. What I will be doing instead is, so this isn't going to work. Next, I'll look at this one. Is it something x plus or minus something y equals a non-zero value? Yes, this is case C. Okay, 1x plus 6y equals a non-zero value. So, I will proceed to use case C. So, do 0 blank and blank 0. Okay? So, x equals 0, y equals we don't know. Okay? Here, x equals we don't know, y is 0. So, 0 plus 6y is 8. So 6y, 0 plus 6y is 6y, and then divide off the y, the 6, and y equals 4/3. Okay? That is equivalent to 1 1/3. So we will have 0, 1 1/3. For this one, I have x plus 6 times 0 equals 8. Well, folks, that's 0. So x equals 8, so I have 8, 0. Okay, I've got two different points, and that's all I need. So 0, left, right, nothing, up 1 1/3 units. Looks like I'm going to be going about right here. And then this will be 8, 0. All right? So, that looks better. All right, so that is example 7. Okay? I'll pause here and put up another one. All right, the next example is y equals negative 2.6x plus 4. So that's y equals an integer times x plus or minus k. Hey, this is it. That's the one I'll use. So 0 blank and 1 blank. Because that's the rule there. So y equals negative 2.6 times 0 plus 4. Well, folks, that negative 2.6 times 0 is 0. 0 plus 4 is 4. So I have 0, 4. Over here, I'll have y equals negative 2.6 times 1 plus 4. Well, that's negative 2.6 plus 4, which is 1.4. So I have 1, 1.4. So here's 0, 4. Left, right, nothing, up 4. And then 1. And then up 1 and 1.4 would be about right there. All right. And there is a sketch of a line. Okay, I'll set up another example after pausing. All right, next up we have y equals negative 5, 6 plus 8. And that, of all the possibilities on this list, it looks like this one. So that's the one I'll go with. So, 0 blank, and the denominator is 6, so 6 blank. All right, so this one means x equals 0, y equals we don't know. This means x is 6, y is we don't know. Okay, so to do this one, y equals negative 5 sixths times 0 plus 8. Well, anything times 0 is 0. So negative 0 is 0. 0 plus 8 is 8. So we have 0, 8. For this one, y equals negative 5 6 times 6 plus 8. Well, folks, 6 divided by 6 is 1. Negative 5 times 1 is negative 5. Plus 8, I end up with 3. So y is 3. So x is still 6, but y is 3. So 0, 8. Left, right, nothing, up 8. And then 6, 3. 1, 2, 3, 4, 5, 6. And then up, down is 3. And then I put the line through. All right. I'm going to pause here and set up another example. Okay, so now I have negative 5x plus 8y equals 40. Okay, so this looks most similar to this. And that's not 0, so I'll use this case right here. So we'll have 0 blank and blank 0. Okay, so x equals 0, y equals we don't know, x equals we don't know, y is 0. Okay, so dealing with this one, I'm going to have negative 5 times 0 plus 8y is 40. And folks, that's 0. 8y is 40. 0 plus 8y is 8y. 8y equals 40. Divide off the 8. And y equals 5. So we have 0, y coordinate 5. Okay, over here. Y is 0, x is the unknown. So negative 5x plus 8 times 0 equals 40. All right, so that will give me negative 5x, that's 0, equals 40. All right, and then I'll divide off the negative 5. Oops, miscopied the problem. Negative 5x equals 40. Divide off the negative 5. And x equals negative 8. So we have x coordinate negative 8, y coordinate 0. So 0, 5, and negative 8, 0. And I'll put the line through. And then I'll pause and put up another problem. All right. So let me change that to 7x minus y. Okay. Now here I have something else. Here I have I don't have y equals, so that's out. I have something x plus or minus something y equals a number, but that has to be not 0 and not 0. So I'm looking at this situation right here. Okay, so I need to solve for y. So I will subtract the 7x, and end up with negative y equals negative 7x. Divide off the negative 1 that's not unstated, and y equals positive 7x, which makes it look most like case A. Something times x, an integer times x. So I'll use 0 blank and 1 blank. All right? So x equals 0, y equals, I don't know. X equals 1, y equals, I don't know. So y equals 7 times 0, which is just 0. So 0, 0. This one will be y equals 7 times 1, which is 7. So I end up with 1, 7. So here's 0, 0. Here's 1, 7. And that is my attempt at a straight line at that steepness. All right. I think I'm going to stop here.